Hello everyone, we're going to graph radical functions. This is section 5.3 of your Algebra 2 class. Remember that in this case we are trying to graph radical functions. We're going to describe transformations of radical functions, and we're going to write functions that represent transformations of radical functions. So we're going to start with some review that we've been doing before. So for example, it says in your own word, define a radical function, give several examples. Remember that in this case, let's not complicate. A radical function contains a radical expression. Okay, contains a radical expression. That's what we're going to do. Also on B, graph each function. How are the graph alike? How are they different? So in this case, I have the square root of x. Remember that the square root of x, I'm going to graph here. This is my x. This is my y. We have done it before at the beginning of the class. We have done it in Algebra 1 a little bit. So the radical function, the square root of x, starts from 0. And it's just a sketch, right? So we're going to have a function that goes this way. This is your function, the radical function. Now I have the cube root of x. So I'm going to have my quadrant here. Okay. This is x. This is y. And now what I'm going to do is, remember, this one it goes through 0, 0. And it's coming from negative infinity, and it goes to positive infinity. That's your graph of the cube root function. Remember that the cube root function, you can have negative numbers and still perform the operation. Okay, so now the fourth root we're going to have here. Remember, this is x and this is y. You have a even index. So we are not going to have a function on the negative side of the quadrant. So it's going to be similar to the square root of x, but it goes a little bit higher than your square root of x. And final is the fifth root of x, which is going to be again similar to the cube root, and it's coming from the negative part of the quadrant, and it goes to the positive, and it goes through 0, 0. Okay, just pass a little bit. Okay, now remember that in this case, if you have a parabola, so I have y equals x squared, my graph is the following one, opens up. Now when you have the radical function, in this case y equals square root of x, you only graph the positive side. It's like rotating your graph horizontally, and you're going to have the positive side. We cannot have the negative number inside. So what we can do is just graph the positive and the negative, and that's how we're going to get a parabola, but laying in the x-axis. So keep in mind that one, we're going to need it. So we have C, match each function with its graph, explaining your reasoning. Then describe G as a transformation of its parent function. So what we're going to have, okay, so the first function, I have square root of x plus 2. Okay, square root of x plus 2 is similar to the square root of x, but it's going to be translated 2 units to the left. So problem 1 in this case is going to be similar to those parabola transformations. Remember that if I have x plus 2 inside a radical, I'm going to do the opposite movement of the sign. So if it says plus 2, I'm not moving to the right, I'm going to move to the left. So the solution for I in this case is going to be A. Can we see that it starts from negative 2? So this is going to be A. Okay. Then I'm moving to the second part, gx equals to x minus 2. So in this case, I have square root of x minus 2. What I'm going to do is take what is inside the radical, x minus 2, and I'm going to equal to 0. I know it just has to be greater than or equals to 0, but I just want to know the sign of that movement. So solve for x. So x is equals to 2. So it's positive 2. So we're going to be moving 2 units to the right. So in this case, my option is F. So this one is going to be F. Okay, I'm going to cross these two out. So F is 2 units to the right, and it's a radical function. Now I have the third part. In this case, I have cube root of x plus 2. The plus 2 is outside the radical. It's outside the radical. That means it's going to be a vertical movement, up and down. So in this case, it's plus 2. That means it's going 2 units up. So which one is this one? It's going to be C. C is going to be the right option. Okay, so number 4, I have fourth root of x minus 2. Again, it's going to be a vertical movement, but in this case, it's going 2 units down. That's the only movement that you're going to use. It's negative. So if it's negative, it's going down 2 units. So which one is that one? Okay, so in this case, what we're going to do is option B. This one is going to be B. Okay, 2 units down. And then I have the fifth problem, gx equals to cube root of x plus 2 minus 2. So I have a combined operation, so 2 operations at the same time. So in this case, I have x plus 2. That means it's moving 2 units to the left. And then I have minus 2, so it goes 2 units down. So in this case, it's going to be E is the right option for this one. So by elimination, in this case, we're going to have that this one is D. Okay, option D. So that's just a review of what we've been doing in class from previous lesson, especially parabolas. Let's remember in this case that if you have a parabola y equals x squared, our domain in this case, domain is all the real numbers, okay, and the range. In this case, we're going to have that y is greater than or equals to 0. So we start at some point and then we go up or we go down. Depends if it's concave up or concave down. Okay, so that's C part. We're going to move to D. We're going to describe, in this case, the transformation of fx equals to square root of x represented by gx equals to negative square root of x plus 1. Then the graph is each function. In this case, I'm going to start with what is inside the radical. So I have x plus 1. So remember, what I'm going to do is x plus 1 equals to 0. So x is equals negative 1. So in this case, we're going to have a movement left 1 unit or 1 unit to the left. So I'm going to start here 1 unit to the left. Okay, and then I have this negative in front of the radical, right? So we're going to have a reflection. We're going to have a reflection, okay? And in this case, it's a reflection in the x-axis, x-axis. We're going to learn that one with the table in a moment. We're just doing a review. So it says graph each function. So what I'm going to have is the following. This is my square root of x. So start here, and I'm going to have this one. That's your parent function, what we call it. And now we're going to have, in this case, the transformation. Remember that this transformation goes 1 unit to the left, okay? And start a reflection in the x-axis. So we're going to start here, and we're going to have the following graph, something like this one. It's just a sketch in that graph and so on. So to graph radical function, now we're going to the formal definition. To graph radical function, a radical function contains a radical expression with the independent variable in the radicand When the radical is a square root, the function is called a square root function. When the radical is a cube root, the function is called a cube root function, and so on. Fourth root, fifth root, and so on. Okay, so remember that the parent function is the original graph of the function, the way we have it here. So this is the parent function of the square root of x, and this is the parent function of cube root of x. So let's do the first example. Remember that to graph this function, we're going to use a table of value. Okay, we're going to use a small table of value, or you can use a graphing calculator. Look at this function. I have 1/4. So I can simplify. What is the square root of 1? Is 1. What is the square root of 4? Is 2. So this one is the same as having 1/2 square root of x. That's the same function. So now I'm going to do a small table of value. Here I have x, I have y. I'm not going to use negative numbers because the negatives are not defined on the real numbers in the radical. So I'm going to start with 0. That's going to be my first number. I'm going to do also 1, and I'm going to do 4, and I'm going to do 9 because those are perfect squares. So I have here 0. What is the square root of 0? Is 0 times 1/2 is 0. So my graph starts at 0. Then I have 1. 1 times, in this case, square root of 1 is 1 times 1/2 is 1/2. So I have 1 and 1/2. So it's here, half of that unit. Then I have 4. What is the square root of 4? Is 2 times 1/2 is 1. So I have 1, 2, 3, 4, and I have 1 here. Now I'm going to start with 9. What is the square root of 9? Square root of 9 is 3 times 1/2 is 3/2, or 1.5. 1.5. So I have 4, 5, 6, 7, 8, 9, and I have 1.5 here. So this is the graph of that function. Okay, that's the graph. Just using a table of value, using perfect squares. And now I have part B. I have -3 cube root of x. I'm going to use a table of value again. So I have x, I have y. Remember that in this case, I can use negative numbers because the negatives are defined on cube root. So for example, if I have cube root of -8, it's going to be -2 because -2 times -2 is +4 times -2 is equals to -8. So I'm going to start with 8. 8. I'm going to have 1. I'm going to have 0. I'm going to have -1 and -8. I'm going to use those numbers. Okay. So I have cube root of 8 is equals to 2 times -3 is -6. Then I have cube root of 1 is 1 times -3, -3. Then I have 0. Cube root of 0 is 0 times -3 is 0. Cube root of -1 is -1 times -3 is +3. And then I have cube root of -8 is -2 times -3 is +6. Okay, so how is the graph going to look like? So I'm going to start with 0, 0. Then I'm going to have when x is equals to 1, 1, 2, 3, -3. When x is equals to 8, 1, 2, 3, 4, 5, 6, 7, 8. Y is equals to -6. 1, 2, 3, 4, 5, 6. So I got this one here. And then I'm going to do the same on the negative side. So I have when x is equals to -1, 1, 2, 3. And then when x is equals to -8. So I'm going to have -1, 2, 3, 4, 5, 6, 7, 8. I'm going to have 6. 1, 2, 3, 4, 5, 6. And now I'm going to graph. So it starts from this part here, from -infinity, and it comes through 0, and it goes that way. Okay, it's coming from the left, -infinity, goes to +infinity. We can do domain and range if we want. So domain on this function is going to be x is greater than equals to 0. Okay, x is greater than equals to 0 because it starts at 0. And then the range in this function is y greater than equals to 0. Now here, this one is domain is all real numbers, is coming from negative infinity to positive infinity, and range is also all real numbers, start from negative infinity and goes to positive infinity. Okay, so that one is the example 1. Now we're going to have some definitions in this case. So we have our table of graphing transformations. So we have horizontal translation, vertical translation. We have the different forms that we have. For example, horizontal translation, so means it moves in the x-axis. So if I have x minus h, so if you have a negative number, moves to the right. Okay, if you have a positive number, moves to the left. So it moves in the opposite direction of the sign that they're giving to us. On the vertical translation is the opposite, because we're going to use, if it's positive the number, we're going to go 7 units up, and if it's negative, we're going down. Then we have reflection, horizontal stretch or shrink, vertical stretch or shrink. Now you can pause the video, look at your tables on your textbook, and we're going to solve example 2. So we're going to describe the transformation of f represented by g. Then we're going to graph each function. So what I have here is fx equals to square root of x. That's the parent function. So this one I can just like graph it at this point. I know this 1, 1. I have 1, 2, 3, 4, and 2. And we can go on and graph this function this way. This is the parent function. Now, the transformation, I have x minus 3. So if I have x minus 3, I have 3 units to the right. So I'm going to 3 units to the right. And then I have a plus 4. So that means it's going 4 units up. 4 units up. Okay, so we're going to have 4 units up. And in this case, if we graph it, we're going to start, this is the parent function. So I'm going to have 3 units to the right. 1, 2, 3, and then 4 units up. 1, 2, 3, 4. This is where the graph is going to start. And then I'm going to have 1, 1, 1, 2, 3, 4, and 2. And we're going to graph the function. Okay, that's going to be my graph for that function. Now I have a cube root of x. Remember that the cube root of x, in this case, the graph that we had was coming from, it was going through 0, 0, 1, negative 1, 1, 1, 1. So it's coming this way. Okay, it's coming this way, and then it goes this way. That's the parent function. I'm just doing a sketch of that graph that goes that way. Now I need to graph this function. So what I have 8 multiplying the cube root of x. So I have 8. So it's stretched by a factor of 4. In this case, the example. But in this one is stretched by a factor of 8. Okay. Also, I have a negative sign there. So it's going to be a reflection in the x-axis. So I have reflection, in this case, reflection in the x-axis. Okay, that's what we're going to have. And if we graph, so it's a negative function. So we're going to have something like, if I put 1, for example, 1, cube root of 1 is 1, times negative 8 is negative 8. So 1 and 1, 2, 3, 4, 5, 6, 7, 8 here. 0, 0, same 1, 1, 2, 3, 4, 5, 6, 7, 8. This function. And what we're going to have is coming from negative infinity, goes through 0, 0, and it goes through this point here. Something like that. This is a sketch. You can do a table of values so we can get that exact graph. Okay, so that's example 2. A and B, we are going to do, in this case, D option. So we're going to have example 3, modeling of real-life application. So we have that the function e of d equals to 0.25 square root of d approximates the number of seconds it takes a drop object to fall d feet on Earth. The function m of d equals to 1.6 times e of d approximates the number of seconds it takes drop object to fall d feet on Mars. How long does it take a dropped object to fall 64 feet on Mars? So what I'm going to do, I'm going to start with m of d, right? I'm going to md, which is equals to 1.6 e of d, okay? So now remember, what is e of d? Is 0.25 square root of d. So I'm going to make the substitution. 1.6 times, I'm going to open up parentheses here. I'm going to open parentheses and I'm going to have 0.25 square root of d. Okay, so if I multiply 1.6 times 0.25 is equals to 0.4. So this equals to 0.4 square root of d. And what is d? In this case, 64 feet. And that's the number that they are giving to us. So I have this one, m of d, or m of 64, is equals to 0.4 square root of 64. So this one, I'm going to continue here. So I have m of 64 is equals to 0.4 times 8, because the square root of 64 is 8, and 0.4 times 8 is 3.2. 3.2. So what is the solution? How long does it take a drop object to fall 64 feet on Mars? It takes 3.2 seconds. Okay, that's an application that we have there. Now, example 4, we're going to write a transformed radical function. So what we have is let the graph of g be a vertical shrink. Okay, so we have a vertical shrink by a factor of 1/6. Followed by a translation 3 units left, okay, 3 units left of the graph of fx equals to cube root of x. Write a rule for g. Okay, so I have that the parent function is fx equals to cube root of x. Then I have that gx is going to be equals to, I have a vertical shrink by a factor of 1/6, so it's 1/6 times this cube root of x. Okay, then I have 3 units left, so what I'm going to have is gx equals to 1/6 cube root of x minus 3, x plus 3, because it's going to the left, so it's x plus 3, and that's going to be our solution to this example 4a. Let's do b. So I have, let the graph of g be translated 2 units to the right. So if we go to the right, it's going to be minus 2, and 3 units down, so minus 3, followed by a vertical stretch by a factor of 2. So we are going to have that function multiplied by 2 of the graph of fx equals to a square root of x plus 1. So fx is equals to a square root of x plus 1. Then I'm going to have now gx is equals to square root of, I have 2 units to the right, so it's x minus 2 plus 1. Now it goes 3 units down, so I have gx is equals to square root of x minus 2 plus 1 minus 3, so is gx equals to square root of x minus 2 minus 2. And what is the final step? We have stretched by a factor of 2. So in this case, all this function is going to be multiplied by 2. So I have gx is equals to 2 times the square root of x minus 2 minus 2. So this is equals to 2 square root of x minus 2 minus 4. And this one is your gx function. And this is what we are looking for on that problem. So if you have any question, let me know. You can send me an email, and I will gladly reply back. Have a good day.